Hey everybody, this is Mr. Charnetsky, and this is Unit 2.2, Lesson 3, Congruence Proofs. So, before we get into actually building some formal proofs here, just a reminder of our methods of proving triangles congruent. We have 4 regular ones and then one only for right triangles. So we have side, side, side. We have side, angle, side. We have angle, side, angle, and we have angle, angle, side. And then our special case is HL, and that's only for right triangles, which is hypotenuse lake. Okay, let's actually take a look at a congruence proof here. Now all we're going to be doing is really repeating our process of figuring out which one of these 5 methods is the correct method. And then from there, all we're going to do in the proof is really justify where we get our sides and angles from. It's really just a formal organization of what we're saying, of why we're saying the triangles are congruent. Now, when we're doing this, the first thing I want to do is mark anything that is given to us. Okay. Now, the first thing that they gave us is JI and IK are congruent. So that's this thing right here. So I'm going to go ahead and mark that with a single tick mark. Okay. My second given is this HI and IL. And I'm going to use 2 tick marks because we've already used a single tick mark. And then that's it. I've used all my givens. So now I'm going to go to my picture and see, is there anything on my picture that I can mark congruent? I see right here in the middle I have some vertical angles, so those 2 angles are congruent. And here we can figure out which method it is. So we have a side, an angle, and a side. And same thing on the other side, side, an included angle, and another side. So this is SAS. So our method is SAS. Now in our proof, all we're going to do is really justify where we got each one of these sides and angles, these pairs of sides and angles. And the first pair of sides is actually pretty easy. It was actually given to us. So JI, side JI is congruent to side IK. And the reason, well, it was given. It's kind of a freebie. And then we saw in the middle here we have our vertical angles. So I'm going to say angle HIJ is congruent to angle KIL. Okay. And that's referring to these 2 angles here that are vertical angles. Last, we have our second given statement. We have HI is congruent to IL. That was also given to us. And so we've justified all 3 of these pairs of sides and angles. So there's our first pair of sides, okay, our pair of angles, and we've justified our other pair of sides. Once we've done that, we can make our last statement and reason, which is simply a statement of our 2 triangles being congruent. Triangle HIJ is congruent to triangle KIL. And we already know the reason for that. That is side, angle, side. Now a couple of things. First of all, I want to notice this statement and this statement, they look awfully similar, but you have to notice that the bottom statement is talking about the triangles, the entire triangles being congruent. This blue statement here is referring only to those vertical angles. That's why we use the angle symbol instead of the triangle symbol. So Just want to clarify that. Second thing, even though I specified it in this order of SAS, these first three statements can really be rotated in any order. It really doesn't matter as long as we check off all three. It doesn't matter. I can put the green one first, then the red one, then the blue one. It really doesn't matter. Okay. And that's our proof. Let's take a look at number 2. Alright, for this one, again, we're going to start out marking on our picture. We have AB is congruent to BC, so I'm going to mark that with tick marks. I also have AD congruent to CD, so mark that. That's that statement. And then I look at my picture. Is there anything else? Well, I look in the middle, and I have a shared side, which I can mark. From here, it's pretty easy to figure out what we have. We've got a side, and a side, and the same thing over here, an S, and S, and an S. So our method that we're going to use to prove congruent is side, side, side. All right. Now in our proof, all we're going to be really doing is just organizing where we figured out all those sides from. So the first side, AB, congruent to CB. Well, that was given to us. Our second side, AD, congruent to CD. That was also given to us. And the third pair of sides, we have BD congruent to BD, which we look, whenever we have a shared side and whenever we say something is equal to itself, we use what's called the reflexive property. And usually in mathematics it seems kind of obvious. Of course something would be equal to itself, but this is kind of useful in geometry to allow us to make a statement of this shared side. Alright, well, we have our first side, pair of sides, we have our second pair of sides, and we have our third pair of sides. So now we can write our congruent statement. And something I forgot to mention, we do need to make sure that when we write our congruent statement that we do in fact line up the letters. Now, thankfully they have it written for us and we can just copy that down. But if you're ever writing it on your own, you do need to make sure that in fact all the corresponding angles do match up. So A matches with C, B matches with B, and D matches with D. Okay. And that would be by side, side, side. Okay. The last two problems, I've kind of gotten them started on for you guys already. So you got the first two givens. You'll need to mark them on your pictures. So for example, this first statement, you've got angle A and E here are equal, or sorry, congruent. So you'd mark those. And you also have AD, equal to BE. So you'd mark those congruent, and then you'd have to figure out what the rest of it is on your own. So take a look at the picture, see if there's something else we can mark, and then put down for a statement and reason. Okay, so that's number 3, and then same thing for number 4. I got you started with your givens, and then you just have to figure out the last two statements. So that's the end of this video.